If you've been watching the market at all lately, you know there's one word on everybody's lips: semiconductors. These stocks are on an absolute tear. But to really get why, you've got to look past the ticker symbols. Today, we're going to dig into the nuts and bolts, the major players, and the one giant reason this current boom might be totally different from anything we've ever seen before.
So that's the million-dollar question, right? It feels like almost overnight, these companies making these teeny, tiny, incredibly complex bits of silicon have become the most important businesses on the planet. What is actually going on here?
And when I say soaring, I'm not kidding. Just look at this chart. The gains are just staggering. I mean, we are talking about absolutely astronomical returns for companies like NVIDIA and AMD. And this isn't just a US thing. Check out the South Korean memory giant SK Hynix. This isn't just one company getting lucky. It's a shockwave hitting the entire globe.
Okay, so to really wrap our heads around this, we're going to follow a little roadmap. First, we'll tackle the basics. What's all the hype about? Then we'll look at how these things are actually made. After that, we'll get into the two main types, memory versus brains. That'll lead us right into the new AI Supercycle, and finally, we'll tie it all together for anyone thinking about investing. Let's jump in. All right, first up, why all the hype? Before we can even talk about stocks, we have to understand the tech itself. So what in the world is a semiconductor? Well, the clue is kind of right there in the name. Semi meaning half, conductor.
At its very core, it's just a material that can act like a light switch, on or off. When it lets electricity pass through, we call that a 1. When it blocks it, that's a 0. And that simple binary language of ones and zeros, that is the foundation of, well, everything digital. The very first computers, like the famous ENIAC, which was the size of a room, used these huge, clunky mechanical switches to do the exact same thing. Semiconductors just let us do it millions of times over on a microscopic scale.
And here's a great little piece of history for you. The relays in that giant ENIAC computer were so big and got so warm that they would actually attract insects. So when the machine would suddenly stop working, the operators would have to go in and literally find and pull out the moths that were causing a short circuit. And that, believe it or not, is where we get the term debugging your code.
So we've come a long, long way from moths in our machines to modern microchips. But how do these incredibly complex little devices actually get made? Well, the industry has this fascinating structure with some very, very distinct roles.
You can pretty much break the whole value chain down into 3 business models. You've got the architects who dream up the chip's blueprint, you have the builders who actually manufacture it, and then you have some companies that try to do it all under one roof.
So first up, you have what are called fabless companies. Now, fab is just industry slang for a fabrication plant, a factory. So fabless means they don't have any factories. These are the brilliant architects. They're the ones designing the blueprints for the most powerful chips in the world, but they don't build them themselves. And this group includes some of the biggest names you know and love: NVIDIA, AMD, and yep, even Apple, which designs its own silicon chips.
Okay, so if the fabless guys don't build the chips, who does? That's where the foundries come in. These are the master builders, the contract manufacturers. Their entire business is built on a single sacred promise. Give us your secret blueprints and we will build it for you. We swear we will never ever compete with you or use your design for ourselves. And the undisputed king of this world is Taiwan's TSMC.
And last but not least, you have the IDMs. That stands for Integrated Device Manufacturer. These are the companies that do the whole shebang. They design their own chips, they manufacture their own chips, and they sell their own chips. The classic examples here are companies like Intel and Samsung.
And right here is where a huge conflict of interest pops up. I mean, imagine you're Apple. You've just designed a game-changing chip for the next iPhone. Who are you going to trust with your most valuable secret? Do you go to TSMC, a pure foundry whose entire reputation is built on trust? Or do you hand over your crown jewels to Samsung, your #1 rival in the smartphone market? Well, for Apple, that choice was a no-brainer, and that very decision helped make TSMC the absolute powerhouse it is today.
And the reason this specialization is so critical is because the manufacturing process it's mind-bogglingly difficult. We are talking about drawing electrical circuits onto a silicon wafer at the nanometer scale. To give you some perspective on the precision needed, it's like standing on Earth and using a laser to hit a specific coin that's just sitting on the surface of the moon. It's an almost impossible feat of engineering, and it's all done by machines from a single company, ASML.
So now we know how chips get made. Let's talk about the 2 main families of chips that are at the absolute heart of this whole revolution. You can basically think of them as the bookshelf and the brain.
So on one side, you have memory chips, like DRAM and NAND.
They're the bookshelf. Their only job is to store information. But on the other side, you have the logic chips, the ones that do all the thinking. These are the brains of the operation, and they include the CPU and its now super famous cousin, the GPU.
And I love this analogy for explaining the difference between a CPU and a GPU. A CPU is like a university professor, an absolute super genius who can solve one incredibly complex step-by-step problem. A GPU, on the other hand, is like an army of 100 elementary school students. You wouldn't ask them to solve quantum physics, right? But you could ask all of them to solve thousands of simple addition problems at the exact same time. And it turns out AI is all about doing millions of simple calculations in parallel, which makes that army of students, the GPU, the perfect tool for the job.
But here's the catch. That army of students needs their math problems delivered to them incredibly fast. Your standard memory, DRAM, is kind of like a single-lane country road. It can only deliver one piece of data at a time. This created a huge traffic jam, a bottleneck. The solution? HBM, or high bandwidth memory. Instead of a single-lane road, think of HBM as a 12-lane superhighway, feeding massive amounts of data to the GPU all at once. This is the crucial missing link that truly unleashed the power of GPUs for AI.
So you take these incredibly powerful GPUs, you feed them with this super fast HBM memory, and boom, you get the AI Supercycle. Now, for decades, this industry has been defined by these really punishing boom and bust cycles, but the argument everyone's making now is that AI has broken that pattern for good.
If you look back, we've had two major demand eras. The PC era in the 90s was all about bigger, faster CPUs. Then came the mobile era, where the big challenge was making chips smaller and way more power efficient. You are basically trying to run a race with sandbags tied to your ankles. But now, in the AI era, which is powered by giant data centers, a lot of those old constraints are just gone. Size and power are less of an issue, and the demand for raw, brute force performance has just exploded.
The old cycle was a total mess. It basically worked like a game of chicken, or the prisoner's dilemma. Demand would start to rise, and every single company, terrified of getting left behind, would announce plans to build a new multi-billion-dollar factory. The problem was, they all did it at the exact same time. And that would inevitably lead to this massive glut of supply, which would cause prices to crash and just wipe out profits for years. It made their earnings completely unpredictable.
But AI completely changed the game. First, the demand for GPUs and HBM didn't just grow, it went vertical, faster than anyone could have possibly imagined. Second, because they were scarred by all those past busts, the manufacturers had been really cautious and hadn't invested in enough new factories. And the result is that for the first time ever, supply is structurally unable to keep up with demand. The entire power dynamic has flipped on its head. Instead of chip makers begging for orders, you now have big tech companies literally begging for chips.
And this, right here, is where it all comes together for investors. Because this fundamental shift in power has massive implications for how the market thinks about and values these companies.
See, in that old boom and bust world, earnings were a total roller coaster. One year you're making a fortune, the next you're losing billions. So you couldn't really value a company on its profits. Instead, investors used metrics like the price-to-book ratio, which basically valued a company on its physical stuff, like its factories. But now, with AI driving this sustained massive demand, the profits are becoming way more stable and predictable. And that allows the market to finally value these companies like normal businesses, using the price-to-earnings ratio. This isn't just some boring financial jargon, it's a profound signal that the market believes these huge profits are actually here to stay.
So, there you have it. We've seen how this perfect storm of brilliant design, mind-bending manufacturing, and an absolute explosion in AI demand has transformed the semiconductor industry from a cyclical commodity business into the very engine of the global economy. The old rules have been completely thrown out the window. The only question that really remains is, how long is this new chapter going to last?